Sabina Hyoju Ahn est une artiste, media and sound artist. En français, je ne sais pas comment on dirait, artiste sonore et média, quelque chose comme ça. Elle est coréenne, comme son nom l'indique. Elle vit en Occident depuis plus d'une dizaine d'années. Et actuellement, depuis 2 ans maintenant, elle est dans un programme de doctorat, de thèse à l'Université de Santa Barbara en Californie, dans un programme de
Media Art and Technology.
Media Art and Technology. Elle développe depuis pas mal d'années une démarche d'artiste qu'elle vous présentera justement donc, dans une minute. J'ai découvert son travail sur en fait le site de résidence d'artistes du Schloss Solitude à Stuttgart, où elle était en résidence was 2 or 3 years ago? Maybe?
Yeah, 2 years ago, yeah.
During COVID.
Yeah.
À l'époque du Covid, au début du Covid, elle était en résidence au Château Solitude à Stuttgart, qui est une résidence d'artistes importante en Allemagne. Et j'ai tout de suite, c'est dans le cadre de ces explorations que je faisais pour trouver des artistes qui travaillent avec justement un petit peu la collaboration de non-humains. Et ici, donc on a un fort accent sur la technologie, mais qui est mise au service de la perception des énergies, des mouvements et des énergies, des mouvements et des significations du vivant sur le plan même moléculaire. Et donc, je me réjouis beaucoup. I'm very, very happy that you made all the way to present your artistic and media strategies to make those living movements and energies perceptible.
Mm-hmm.
Yeah.
Yeah.
Thanks very much. Donc, on va avoir, just a second. On va avoir une présentation d'environ about 40 minutes, you said?
Yeah, 30
like
to 40, I think.
Environ entre 40 et 45 minutes avec vos questions, et on va enchaîner sur une performance sonore rapidement après. Donc voilà, ce sera un package comme ça.
Yeah.
Voilà, et moi je vais m'asseoir à ma place. Thanks very much.
Okay, thank you.
And it's your turn.
So hi everyone. Nice to meet you, and thanks for inviting me, and thanks for the nice introduction. I couldn't understand, but I think it was really good. So, and my name is Sabina Hyoju Ahn. I'm a media and sound artist who mostly creates the sound and the sound installations and performances. So today I'm going to talk about my works and how I transform the biological materials into artistic representation. I'm interested in hidden patterns or rules in natural elements and translating them into perception experiences. So in my art practices, I often use biological materials, combine them or connect to machines or like interfaces and transform them into perception experiences. So my works are focused on physical nature of the human perceptual system, which is driven by post-digital media concept with the scientific methodologies and artistic representations. So before I start my talk, I want to show you some keywords of my work to help you understand them. So I have categorized my works by method from 2014 to 2022. So I want to show you all my works, but many of my practices. So please bear with me. I studied the computational arts. So in my earlier works, I was interested in creating computational recursive patterns or iterations found in nature and focusing on computational aesthetics. I think it was a good start in realizing my ideas. So this is an interactive audiovisual installation called Aesthetic Network, made based on generative algorithms. Yeah, so the algorithm creates a super.
Excuse me, that was a recording.
Oh, yeah.
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 And someone was doing things.
Yes.
Mouse to right.
Yeah, so it's a mouse interaction. So if you click it, and then you can choose the different kind of cluster, network clusters, and then it depends on the where you click it. So the nodes between nodes, they calculate the distance and then creates a different sounds. Yeah. So like the algorithm creates a super network system, like motivated by scale-free and smaller network theories. So these network theories can be found in social and biological levels, such as microorganisms or blood vessels, like in living beings, and internet like network or neural network in macro levels. So this structure is expanding infinitely from a hub of the local clusters. The connections are created by algorithms that can calculate the nearest nodes, and the sound is generated by the position of the node. So you can like play with endlessly. So the idea came from the network theory. So if you search for the network theory, you can easily find these pictures. This is a mapping of the internet worldwide. So it is really interesting that this picture is similar to our neural systems. So I use the computer software programming language to visualize or imitate the algorithms found in nature, such as like fractal algorithms, L system, chaos theory, and so on, and network theories, among others. I was fascinated by the network systems that forms our society at different levels. So this is network theories and formulas that are implemented in this work. So, and this is like this generative animation is made based on the L system. So this work represents a mathematical beauty and visualizes the fractal algorithm. So like based on the L system formula, like I modify the numbers and parameters to visualize it. And the moving image makes recursive pattern and keeps generating in real time. So it's like you can, like it's also like kind of interesting. You add the branches, and then adding more branches is like creates a like different kind of patterns like this. So like those are really simple one line of the formula, and you can make this kind of complex pattern. So L system is growth pattern of various types of simple multicellular organisms, such as bacteria, plant cell, but it also describes complex branching structure of trees and growth processes of plant development. Like in this video, trees grow with certain angles, and if you keep repeating it over and over, it creates a dynamic system that looks like chaos. So L system is one of the fractal theories. Fractals are never-ending patterns that makes infinitely complex patterns. So they are created by repeating a simple process in an ongoing feedback loop. So it draws a dynamic system that can be chaotic. So this was the L system that I implemented for my work. And this is a photo of the exhibition at Beaux-Arts in Brussels. Yeah, the theme of the exhibition theme was the mathematical concept in art. So how artists implement mathematical theories into their own artworks. So this was a very interesting exhibition, but unfortunately I couldn't go myself because of the pandemic regulations at the time. Yeah, and later I wanted to add some kind of physicality to my work, and it naturally came with DIY cultures because as an artist, it is really important to visualize your own idea that cannot be found in existing products. So, and most importantly, when I use the biological materials, I need to make a customizable interface between the living being system and human perceptual systems. So my interest got more into making physical objects rather than making pieces only in a virtual environment. So I wanted to make them tangible and add more physicality and hybridity. So I made an interactive installation called Breath in 2015. This is an installation, also performance, which is operated by my breath. So this work is made of the electronic waste, such as old computers, telephones, and cassette players. I collected these machines on the street or garbage collection places. At the time, I lived in London, and usually there were a lot of electronic waste on the street. So I could easily pick them up for my materials for free. And I gathered electronic parts from old machines and recreated this sculpture by mixing those parts. So the concept is blowing into the machine and vitalizing the dead materials back to the life. So this is the first version of the breast installation. And I had a curator in London who saw this work and asked me to turn it into sound performance for his event. So I revised the interface by adding musicality that can control light and sound by my breath. So this work evolved many times from a fixed installation to an audiovisual live performance, and there is a feedback loop between light bulbs and visuals. The bulbs are dimmable. The bulbs are dimmed by my breathing intensity, and the visual color changes depends on the light source information. So there are some more additional DIY devices such as hacked web camera, electromagnetic pickup, and the intensity of the light bulbs is translated into other sound sources triggered by computational algorithms. So it's mixed media with the analog and digital device. So here is a clip of my breath performance. I performed in Berlin for Transmedia and CTM Festival in 2000. Yeah, so and art science collaboration. So when I develop my work, it requires professional scientific knowledge because raising a biological things such as bacteria, microbes, and plankton, they need to be in specific conditions. So naturally, I started collaborating with scientists to make sure I didn't fake any basic scientific facts and to implement scientific methodologies into my work. So from this work, almost all my works are made by collaboration between scientists. This work is called sonomatter. It's about sonic transformation with living matter. So in this work, I used mud as material to create sound. So I will show you a video of this work first. like what you heard from my performance video. So it's like installation and performance work. So what you heard from my performance video was electrical energy from the microbes in the mud, the columns. And for this work, I made a circuit that can translate the bioelectricity from soil bacteria into sound. So a microbial fuel cell model is implanted in each column to measure this electricity from bacteria. And the electrical signals are connected to oscillator circuit I made. So bioelectricity controls the oscillator. So this circuit measures the voltage from microbes, and the voltage controls the sound of the oscillator. So also this circuit consumes the energy from the microbes, the column. So as the electrical energy decreases, the sound also gets slower as time proceeds. So this is kind of like physical model of the sonification. So the easily explained, so I made some kind of like system. So I measure the bioelectricity, the bioelectrical energy from the microbes, the what you saw in the video, these columns. So each column is like a microbes. And then I put the kind of electrodes and then connect it to a circuit. And then this circuit like measures the electrical energy from the microbes and then change into the sound. So I'm gonna go over slowly. So and yeah, then I'll show you the demonstration. What I did in this video, like by putting my fingers, I'm adding the voltage or like interrupting the plus minus, like the polar. And to show like how the electrical energy, how the electricity influences the sound. So the system what I made is like works like that. So you can add the voltage, or depends on the amount of the voltage, the sound can be changed or gets slower or faster. When I was working on this project, I wanted to find a way to sonify the bioelectricity as pure as possible, so without using any like computational tools. Because using computational tools is very convenient and easy, but then you can also you can do anything with it. So I would say it's not really pure as possible. So I want to make it kind of pure like sonification tool, like with using like physical interface. So I choose to build a physical interface instead of using computational process. And I used the two scientific methodology in this work with help of microbiologists. One is the Winogradsky column. The Winogradsky column was invented by Sergei Winogradsky like back in the 1880s. And this is a very simple device for culturing many different types of bacteria in a jar, like this column. So you can build it yourself at home also. One of the best part of using this bacteria column for an art piece is that I can grow a large number of bacteria outside of the laboratory. So I don't have to worry about any kind of contamination or other sensitive conditions. So making a Winogradsky column is very easy. So you just need to find the pond nearby where you live and collect some pond mud and pond water, and then mix them with some like newspapers and egg yolk to supply nutrients for the bacteria. So the bacteria grows based on calcium carbonate and calcium sulfate. So most of the living beings, including human, we feed like based on like carbonate and the sulfate. But yeah. And after mixing it, put them under the sunlight for 2 to 3 months, and they will go through a chemical process and develop many different colors of the bacteria. In my case, I made the Winogradsky columns in South Korea and Austria and Netherlands. The development of the microbes could be different depending on the soil quality in the local area. So during this development process in the Winogradsky column, electrical energy is produced as byproduct. So this is called the bioelectricity. So this can be measured in any kind of living organisms. So like EEG, like this kind of stuff you're measuring in your brain and stuff, it's possible because of we produce some small amount of the electricity. So including human, any kind of living organism can be measured. In Sonometa, I transformed this electrical signal into sound by using a microbial fuel cell and oscillator circuit I made, I showed you before. And the maximum voltage I measured so far was 1.127 volt from one column. So it's a pretty high value because with these two columns, you can light an LED light. And the second methodology is MFC. It's called microbial fuel cell. So MFC is a device that converts the chemical energy of microorganisms to electrical energy. So I came up with the idea of using MFC because of these two gradients, the water side and then the mud side in the Wojnarowski column. The membrane between the soil and water is just the same as a typical MFC model, so which usually has an anode and cathode. I place a 99% carbon fabric anode at the bottom of the column and connected to cathode in the water. So each column is working like a bio battery. So I use like a 5 to 10 columns. So each column is kind of like bio battery, which produces like 1.5, 1.7 volts. And for the performance setup, I use an interface developed by Lex van den Broek, who was my electronics teacher when I was studying the master's program in Netherlands. By connecting this interface, the analog signals from the bacteria can be changed to digital. So therefore, I can control the sound for multiple sequencing between columns at the same time. So it's like what I measure, this electrical signal is like an analog. So it's like all those circuits are analog circuit. And then to control with my computer, like specifically using the MaxMSP program, I need to convert this signal into digital signal so I can control with the computer. So that's why I'm using this interface. So I can control like all those 10 columns at the same time, like it's a sequencing for like 1 to 2, 2 to 4, like something like this. And the whole process of the bacteria generating electrical energy is the same as the fermentation process. So it illustrates a circular relationship between the life and death in mud. You can visually see like various layers, and each column means different bacteria are growing in it. The bottom layers are related to upper layers. So the upper layers bacteria can grow based on the bottom layer bacteria. So what I see like in the earlier these things, so you can see all different kind of bacteria in a jar. So each color represented the different kind of the bacteria, and then they all related to each other. So the bottom bacteria, so the second layer of the bacteria can grow because of the bottom bacteria, so this kind of relationship. So, and also in water side, there's some like algae and like cyanobacteria. They do the like photosynthesis, and then it's a whole kind of making kind of ecosystems. Yeah. Each column is a kind of perfect small ecosystem that can be self-sustainable. And then they generate the electricity like for my case, like almost like 5 years, they stay alive. So without injecting any nutrient, so they are very sustainable. And this is my other work called DIY BioNoise, and it's actually developed from the sonometer. And I wanted to use my own electrical energy from my body instead of the soil bacteria. So this is customizable electronic music instrument and has 2 different modes. One is normal synthesizer mode with an 8-step sequencer, and the other one is BioNoise mode. So I can control the noise with my fingers. So I'm using, so it's like your body, everyone's body, like generating small amount of the voltage, and I'm using my voltage like by using my fingers, and just like control the noise as a like a musical instrument. So I'm going to show performance, and actually I'm going to show this performance later today after this lecture, like those the setups I'm going to, but it will be revised version. So I modify my instrument into the Eurorack case, so I can bring it in one box. Actually I have to excuse like about the sound system here, so it won't be really like best sound quality here, but I'll do my best. And this is my handmade schematic of the instrument. DIY electronics are also a big part of my work. So I try to experiment with many aspects of the technological solutions. And DIY has come into play in order to build an interface between the human senses and imperceptible data. Yeah. In the video, so I also visualize the audio signals into RGB signals, so it reacts to the sound. Yeah, this is a picture of a performance in Japan during the pandemic time. So I was supposed to go there and even got a visa, but ended up not being able to go because Japan completely closed the border. So I had to take a video of the performance and broadcast it at the venue. Like as a sound performer, I really hate this kind of performance. Like the online performance, it was really horrible. And yeah. And also this became a way to share ideas about handmade electronic circuits. So I gave a workshops for people who doesn't have any backgrounds in electronics. I teach some basic electronics and how to make your own electronic music instruments by using electronic parts. So people really liked it, and there are really diverse people in gender, and I really enjoy it, like giving the workshop. And this work is called kilohertz because I used the ultrasonic frequencies that cannot be perceived by human ears. This work explores the relationship between microorganisms and sound and tries to explain how sound waves affect the microorganisms' environments, especially by man-made sound in the ocean, such as noise from the ships and drilling for oil, gas, and other resources in the ocean, stuff like that. I heard that those makes a lot of noise, and it's harmful for also sea living beings. And yeah, I'll show a video. So bioluminescent algae are plankton living in the ocean, and they make a light when they are agitated. So when they shake, then they make light. So I make them shiny by using ultrasonic waves. So there's a algae, bioluminescent algae, and then I put the ultrasonic transducer at the bottom of the algae, and then they shot through the algae, and then they make light. The algae visualize the inaudible sound, so ultrasonic sound, we cannot hear the ultrasonic and infrasonic sound because it's too high or too low. So, but then I visualize the inaudible sound by using the algae. But at the same time, they are dying because it's too high frequency, working like a sonic weapon. So it's in the earlier video, it was making blue light, and then now it's yellow because they're all dead. So because it's working like a sonic weapon, it's too sharp. Yeah. Yeah, I mean, it's a kind of metaphor. It describes the relationship between the like noises, like which created by the human maybe, and in the ocean like environment, how like human man-made sound can affect the creatures in the ocean, like because we never thought about it, right? So yeah, it's kind of thing. So the movement of the shining means like death for them of the cells. Like each cell is destroyed by the ultrasonic frequencies when the frequency like penetrate them. So in the end, all cells are dead. So they no longer make light like this yellow juice. And yeah, this is the microscopic photo of the bioluminescent algae I have taken, and it will be a great experience if you have a chance to see how they make light. I think for me, the color of the algae, the light, it's not the color you can see in the land life. I think it was really beautiful. And this is the mechanical system I made to control the ultrasonic frequencies. It's basically kind of timer. It's also handmade DIY, and some photo of the installation for an art exhibition. Yeah, and yeah, this is kind of my recent work called plastic signals. This work is unification of interaction data between human proteins and pathogens such as the bacteria and viruses. This is kind of serious work that I developed with scientists for the last 3-4 years. And the first series of the work I did was to sonify the interaction data between Borrelia bacteria and human protein molecules. The Borrelia bacteria is a pathogen that causes Lyme disease in human. I don't know if you have ever heard like Lyme disease. It's by what's called second tick. Yeah, tick. So yeah, so my scientist collaborator measured the binding force between Borrelia bacteria and human protein molecules by using a device called AFM. It's called like atomic force microscopy. And this work is on the smallest scale of living beings I have ever worked so far. It's a nanoscale. So even with the microscope, we cannot see it. So that's why they're using AFM, because it's not optical. It's more like a tactile on the observation. So in this domain, I cannot control anything without scientists. So this work tends to be more like academic and scientific than anything I have done before. So the AFM is kind of microscopy technology, but it's not optical. It can directly touch the single molecules like this at the molecular level. And scientists use it to see the shape of the single molecules or measure the binding force. So this video shows how AFM works to read the surface of the molecule. So it's like they using like a kind of LP electrode player, and then they scan it, the surface of the molecules. And next clip shows how the AFM works to measure the binding force. So this method we use it for this work. And in this process, a pathogen hangs at the cantilever, and the protein molecules is at the bottom. So when the scientists try to attach and detach them, a certain force generated, and this is called the binding force. So they try to like attach and detach, and then when they try to detach them, there's a certain force like generating, and then they measure this force. This force means these two molecules like don't want to be separated. They want to stay together. So the reason why scientists are working on this project is to know like how pathogens works in our body, like in the host body, for example, how they hide into like human body or like host body, and how they when they start attacking the host, and how they communicate with each other. Like nobody really knows how they works, like what's the mechanism of the pathogens in the host body. So and also there's no cure yet for Lyme disease, so that's why they're working on this. And so I received the data sets from the scientists, and the data basically contains a lot of numbers. It's a lot of numbers. So because the measuring scale is nanoscale, it's really, really small, so which means super, super small, then there's a lot of noise that can be detected, such as like thermal vibration in order to in the very, very small scale, we think that there's nothing happen, but there's a like constant like vibration in the air and everything affect on the measuring observation. So even those noises, they can detect it by these using the AFM. So there are a lot of different kind of numbers.
What numbers measure exactly?
They measuring actually kind of like the vibration of the cantilever. So this in the AFM. So this cantilever kind of makes their own vibration to measure it. And then because this is really, really small scale, so in the air, there's already some kind of vibration, right? In the air, it's kind of full of the different molecules, right? So there's a constant vibration. It's called thermal vibration. So they call this thermal vibration. And then there are a lot of different kinds of noises and so it has to be some kind of, so if you see the AFM, it's in the box, which is the noise canceling box and the vibration canceling box. But then still, if you make something like near around the AFM, like something like this, it can affect the also measuring process because it's really, really small scale. So in order to sonify those data sets, I have to analyze the data and filter out which numbers are important and which are not. So as you can see, the data is almost noise, but there is a point scientists are looking for, and that is the moment when the two molecules are separating. The artistic research of this work focuses on examining like interspecies relationships in parasitism, and seeks to view them as mutualistic and long-term relationship, like rather than solely negative effects on the whole side. Because like human and other species, especially for parasitism, like we think that like with the human perspective, we only think that like the pathogens are really bad because of human, because it causes a lot of different kind of disease. But actually, if you're looking at the history of the parasitism, it's like kind of, it's mutualistic. It's not only one bad way from the pathogen to the human side. So we kind of like exchange all kinds of informations between the pathogens or other species and between humans. That's how we evolve like through the whole history. So in order to sense the signals at the human level, the signals need to be translated. The human senses are very limited to certain range, so the data should be converted or perceptible. So human can detect frequencies from 20 to 20 kilohertz. If you are young, you can hear more, but the frequency sensitivity will lose as you get older. So we only hear things between like very small narrow range, but for example, some whales can hear 16 hertz to 2000 kilohertz, and most bat calls can range from 9 kilohertz to 200 kilohertz, which is beyond the range of the human hearing. Only human vision is limited to very narrow range compared to other species. Because the V's area, that's the only area we can see. The other area we cannot see, but other kind of species like microbes or other things they can see. I mean, they move in this frequency. Yeah, so I had to work on this audible range for human audience. So I made 2 sound engines based on sonification methods. They are called PHYSIM, which means physically informed sonic modeling, and feedback-based sound engine. So PHYSIM has 2 sound sources, and feedback engine has 1 sound source. It sounds like very complicated math terminology, but basically it just mapped the data values onto the sound elements like density, speed, and levels of the sound and so on. So this is the first sound sample. And this is the second sound sample of the PHYSIM engine. And this is the sound source for feedback engine. Yeah, so the measured signals were like transformed or sonified by using software called Super Collider. and distributed into 4.1 like quadraphonic channel sound installation. And here's some part of the work that I sonified the data into sound. So these are the data, and the number shows like how I like sonify these numbers into sound. Yeah, so there are some photos of the exhibitions. I made this work during the residency program at the Academy Schiller Solitude in Germany, and exhibited in a beautiful barn at their institute. So this is like their barn, and then it's really perfect for the sound installation. And the video
Mutation ist ein Thema, was wir vor 2 Jahren gesetzt haben. Also etwas, was wir nicht aufgrund der aktuellen Situation der Pandemie entwickelt haben, sondern lange im Voraus. Das zeigt uns, inwieweit Kunst eigentlich vorausschauend denkt, welches Potenzial eigentlich dahinter liegt, dass Kunst letztlich Schwingungen aufgreift und sehr früh umsetzt in nicht nur Kunstwerke, sondern auch Gedanken und Aktionen.
Yeah, it was a really good program. It's we worked on the theme under the mutations. So like 7 different artists, including me, from different kind of art disciplines, and then we work on the subject, the theme on the mutations, and then develop the work, and then had exhibition there. And this is the work called Coexistence with the SARS-CoV-2 virus. This is the second series of the parasitic signals. It's a continuous collaboration with the same scientist, but this time the subject is the coronavirus. We wanted to explore the relationship between the coronavirus and human, especially under the pandemic conditions. But because during the pandemic, like coronavirus was extensively researched in the bioscience domain. So also my collaborator, who is a researcher at Johannes Kepler University in Linz, Austria, and I decided to focus on this topic. They have been working on the characteristics of the coronavirus, measuring the binding force between the coronavirus and human protein molecules. So using high-speed AFM, they were able to capture the world's first real-time video of the spikes of the coronavirus and the moment of the docking with the human protein called ACE2. Yeah, so this small little thing is the human molecules, and then this big thing is the corona spikes, and then it has a trimer, the 3 spikes, and then it's like looking for the human molecules, and then they kind of docking each other, then they can enter into the human cell. So they can observe how the coronavirus moves and how it finds the human protein molecules. So the coronavirus has a trimer structure with the 3 spikes, and its receptors are designed to fit the human molecules. So this enabling it to enter the human cells, and that's how we get sick from the coronavirus. So the process of this work was similar to the previous one, but with the addition of the visual elements. We received the data sets from the scientists and transformed the numbers into audiovisual simulations. Here is a work in progress of the simulation. So it started with spheres and very simple spike structure. It was just like starting stage. And some little parameters you can control with it. Yeah, and then we began designing the details of the human cell structure using C++ programming language. It was a heavy programming process. Personally, I didn't really like using only computational simulations, but for this work, due to the small size and the large amount of data, the computational process was inevitable. So many people also were involved in this project. So the work contains different aspects of the aesthetics from scientists, engineers, and artists. And this is the teaser video for Media Art Festival last year in Linz. So this is like a human cell, so human lung cell. So we created kind of like a human lung, one single cell space, and how the coronavirus like invaded in the lung, and then how they can enter into the lung cell. So there's a lung cell, and then there's a kind of like hairy things called cilia, and then there's a like kind of layers called mucous layers, and then when we to get into the this in the human cell, they have to find the ACE2, the human protein molecules, and then they kind of like combine, docking each other, then they can enter into the human cell. That's how we get sick. Yeah, so actually my programmer didn't like this video because it's not in its finished state. But as an artist, I kind of like this love stagey like ongoing process video, because I think it conveys more to the audience than showing all like perfect virtual work, especially for teaser. And the artistic concept of this work is to examine the interspecies relationship in parasitism. It's like same as the previous work, and which particularly deals with our current and post-pandemic life with coronavirus and how we might control this our coexistence in a virtual space. And this is the final simulation that we should vision. Yeah, it's a time to time. I'm just playing here. Yeah. I think so. Yeah. And this work is also interactive, so audience can control the coronavirus with their voice, like this, or visitor controller. And yeah, there are some like mentions in Austria. And finally, this is my latest project called 95% Happiness. I also collaborated with a scientist from Korea Research Institute of Bioscience and Biotechnology for 2 years. This work is about relationship between the gut bacteria and the individual's feelings, especially about happiness. So I was fascinated by the fact that 95% of the serotonin is produced in the gut, and only 5% is in our brain. So serotonin is one kind of neurotransmitter. It's like a hormone that plays a crucial role in regulating the mood and appetite and sleep and other like physiological functions in the body. So that's why the title is 95% Happiness, because I collect my own gut bacteria, which involves serotonin production, and show it as my 95% of happiness. So this jar, this small little liquid is like my 95% happiness. So I would like to show a video documentation of the first.
95% of serotonin.
Yeah.
95% Happiness
yeah.
is an art project, exploring the connection between the gut microbiome, emotions and mood, and using artists' own experiences to create a tangible representation of happiness. The artist Sabina Hyoju Ahn collaborated with Dr. Du Sung Park from CREAA Research Institute of Bioscience and Biotechnology on the connection between the gut microbiome and mood. The inspiration came from the fact that certain gut bacteria are known to be involved in cognitive and social functions, such as depression, autism, and schizophrenia.
아니에요.
이번 거?
저번 거는 냉동.
Some bacteria in the gut produce serotonin and dopamine, which are neurotransmitters that can affect our mood. It's estimated that 95% of the body's serotonin is produced in the gastrointestinal tract, which is why the gut is often referred to as the second brain. The artist has a personal connection to the topic, as she has been diagnosed with panic disorder and depression, and her health has deteriorated over the last 3 years due to a combination of irregular eating habits, a monotonous diet, and frequent moves between countries. Over the last 2 years, she has been working to recover her health and monitoring her gut microbiome status under different residential and dietary conditions. To her surprise, the data showed that her gut microbiome gradually became more balanced and diverse as she recovered from her psychiatric symptoms. In this work, the artist shows the interplay between gut bacteria, personal emotions, and mood by analyzing her medical records and gut microbiome samples from Germany, South Korea, and the United States. She collected samples when she was in her healthiest state and cultivated the healthiest Bacteroidetes cluster among her gut microbiome, which is known for producing serotonin and promoting feelings of contentment, satisfaction, and emotional stability. Through her 2-year collaboration with Dr. Park, the artist aims to represent her 95% of happiness in a bottle, turning the abstract concept of happiness into a tangible form and sensory experience.
Yeah, so those are particles in the bottle. It's the gut bacteria of mine. So like this work took 2 years to collect the gut bacteria from different places in the world. So and compare them with my psychiatric symptoms and how they progressed in relation to my gut bacteria spectrum. So like my lifestyle, so I've been traveling like so many different countries. I live in like many different countries for the last like more than 10 years. So I think that's why my like my sleeping habits and eating habits and my lifestyle is very deteriorated. Like it's because of the between the countries. Because I'm having jet lag too frequently, like these kind of things, it's affect my gut intestine environment. It might be that's why it's caused the panic attack. So it's because of I traveling so much. I took a flight before the pandemic. I took a flight like I don't know, like 2-3 times at least, like a long flight of months. And then I traveled in whole European countries, like for the exhibition and performance and stuff like that. And then, so like last for 2 or 3 years, I didn't have the home. I mean, the place I can call home. I just like every 3 months, like I hopping the other places to places. I think that's why I kind of like ended up by having like panic attack. So why I'm having a panic attack, it's like it was really hard to take the flight, and then I couldn't drive at all. And now I starting my treatment, and then it's got much better. So now it's almost fine. But then when I think about that time, I was really having a hard time. So this chart is one of the analysis of my gut environments when I was in Germany. from 2020 to 2021 and South Korea in 2021. I was diagnosed with panic attack and depression in 2019, but the symptoms started in 2018. So I guess it was caused by too much frequent traveling and irregular lifestyle, such as fluctuating eating and sleeping patterns. So I tried to get better since 2019. And when I was in Germany, I still had some panic attack symptoms and was in the process of recovering my health. So as you can see, the chart shows that when I was in Germany, my microbiome was much simpler than when I was in Korea in 2021. So when I went back to Korea in 2021, it became more diverse. So like diversity is much more better than back in the 2020. And my scientist says it's an ongoing research project to find the exact gut bacteria clusters that produces the serotonin. And in the therapeutic domain, they try to synthesize a natural serotonin for patients who suffer from like psychiatric disease, because the serotonin is one of the most popular medication, like Prozac. You have heard about Prozac. It's about like serotonin. So it's it's a different mechanism anyway. The core thing is about serotonin, is to control your serotonin levels. So that's why so many people like they taking the serotonin consumption serotonin thing. It's called fluoxetine or Prozac or stuff like that. It's to control the serotonin level. So if you like people can find some kind of natural serotonin from your body, then it could be much more healthier, it might be. So that's why they're working on this kind of like project, your researches. So like there are some cluster like this, the things on the highlighted cluster concern to produce serotonin, but scientists said it's not easy to say which bacteria is good and which is not good, which is bad, because the entire diversity and balance are more important than having certain cluster of the bacteria. So doesn't matter like how you have how many you have a good bacteria cluster. There's no kind of like only good bacteria cluster or bad bacteria cluster. It's really important to having a lot of different kinds of like diverse of the microbiome balance. So if you want to be healthy, so it is really important to eat balanced diet rather than focusing on one favorite food. So it's good to eat a lot of vegetables and a lot of fiber. That's what my scientist said. So and this is another analysis. When I was in the US and Korea, I became very healthy in 2021 and 2022, and my symptoms are almost gone, but I still have some difficulties, but much better than before. So an interesting thing is that I also collected my bacteria right after I got COVID in the summer of 2022. And it's totally changed my gut environment. So you can see that it's imbalanced, like it's really imbalanced, like back in 2020. So I also read some articles that said the coronavirus affect the gut environment. So people may experience related symptoms. So yeah, and I think that's why I really don't like the coronavirus. It's ruined my environment, because I try so hard to keeping this balance like for like 3 years, and then like one shot of the coronavirus, and then it's ruined my gut bacteria. And then I collect the gut bacteria samples and culture them in a different types of medium. So this is solid medium called agar. And I decided to culture them in a liquid medium. So like it looks like something you can drink, but actually it's just metaphor in our project. You cannot drink. I took some electronic microscopy photos of my gut bacteria. I referenced this image when I made the data visualization of my microbiome status. So having healthy gut bacteria is really important. If you want to be happy or feel happy, it is hard to define what happiness is, but I wanted to like turn the abstract concept of the happiness into tangible form and sensory experience. So my gut bacteria samples are kept in research facility at super low temperature, like you see on the video. And actually anyone can order them through the bacteria bank in Korea. So these are the consultation notes and medical records from my doctor in Korea. And I made a book of the records microbiome chart and the photos to show like how my symptoms changed over time. So those are like doctors' consultation notes, medical history. Because it's really funny that psychiatric doctors, they made a whole notes like during the consultation time. So there's also something very details about my status. So it was really funny to read actually. And then some photos and then all the materials I made during the project. And to prevent my bacteria cluster from sinking and getting stuck in the bottom of the bottle, so I designed custom-made shakers using a motor. So it's like there's a plate and the motor is like moving like this, so it's to prevent from the sinking down on the bottom of the bottle. Yeah, there's some kind of working process and some photo of the exhibition. Yeah, so it's like it's moving like this, it's working like this. Because you cannot really see through this video, like there's a particles, small particles, that's the bacteria. And then if you just standing alone, and it's getting sink, so it doesn't look good. So you have to keep shake them. And this is a data visualization video of my microbiome history. And it shows how my gut bacteria changed from 2020 to 2022 from two different perspectives. So the first one is cell division. It shows how the cell dividing, like multiply. And yeah, this is show how which cluster increased or decreased. Yeah, and I also recorded the sound of my gut and played it through the tactile speaker, so that the audience could feel the vibration of my intestines. So if you touch the wall is vibrating with this speaker. And this is a photo of the exhibition last year. And yeah, that's it. So thank you very much for listening. So now I'll stop talking. And if you have any questions or thought, anything, I'm happy to hear them.